Thank you for joining. My name is Andre and I will be your moderator today. Today's session is titled Sponsors Presentations. We will have 3 presentations. The first one will be called Better Together by Susanne Trierscheid from Bentley Systems. Then we'll have How BIM and openBIM have been transforming infrastructure design by Mauro Coletto from SierraSoft. And last but not least would be Jeffrey Avina from LeapThought with a presentation on open standards and then interoperability. This session is scheduled to last 90 minutes, including time for questions at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to the speakers, I would like to remind you that this is a hybrid event. For online attendees, your microphones will remain muted for the duration of this session. If you wish to make a comment or ask a question, please use the chat box in the control panel. For the attendees here in the room, please keep background noise to a minimum, and if you wish to make a comment or ask a question, please raise your hand and use a microphone. We would like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent, that standards that are developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct. And now I would like to hand over to Susanne.
Thanks for the introduction, and thanks everyone for being here. I recognize that this is a bit of a tough spot with like 6 presentations going on in parallel, but I'll treat you like you were like 200 people. As the colleague already said, my name's Susanne Trierscheid, and he pronounced my name pretty well. I'm the Vice President of Modeling and Facilities Engineering at Bentley Systems. I've been with the company for 23 years, so a long time in the industry and a long time with Bentley. For the last 4 years, I've led the product team in charge of MicroStation and a few other open applications. So it's desktop applications, modeling applications, so obviously the tools that we use to produce a lot of data. So for our tools, IFC and open standards are absolutely vital. But aside from the stack of my software products, today I actually want to talk to you about open standards in infrastructure and how they matter when it comes to AI and how important it is to have open standards and open data to really unlock the full potential of AI. Are any of you familiar with the AEC Advisor's annual State of the AEC Industry Report? Of course. Thank you. Anyone else? Well, it's pretty insightful. So if you get a chance and you're interested in data and numbers, then have a look. I stumbled upon this set of data when I was just doing research for the presentation, and it stood out to me. This diagram is part of a survey where the AEC advisors checked in with 340 AEC firms and their CEOs. And as you can see, data management is actually the most important technology priority at the moment. It's kind of obvious, right? Many of the data management and data usability issues across our industry start with data being locked into proprietary formats. And that's where the need for openness comes in. Generally, however, there's a lack of openness, and therefore a lot of valuable information and insights that could and should be used in other phases of the infrastructure life cycle, always a mouthful, is not easily accessible or maybe not at all. And many of us are here this week for just this reason. And this isn't the only reason why open approaches matter so much. The infrastructure software space is characterized by a diverse number of vendors. And these vendors even have more products, and all those products are often used simultaneously, but not necessarily all products, even from the same vendor, are compatible with each other. And that phenomenon that you have a lot of different applications is not going to change. I think it will actually get even worse because with emerging technology and emerging startups doing really exciting stuff, you will have more and more technology maybe just solving one problem, but solving that problem in the best possible way. So to drive new technology, to help us on the whole digital transformation, and to make sure you have access to that, we need to be open with our new technology. That is, in a way, a win-win. If it's open, you have data you can access, but it's also a win for us vendors to be able to get value out of software we produce, but also to enable you to get value out of software we produce. So the best approach for us at Bentley is to develop solutions that meet these needs today and that provide these flexibility and data openness. What we mean by an open approach, actually, sorry, that was a bit too quick, is that you can use open standards where everybody authorized to access the data can actually read and understand it. We are also committed to embracing open source where leveraging data is approachable for all developers. And we're committed to exposing open APIs to not only let users query data, but also to take it out of a digital twin if they decide to do so. And this is why we have, and you may have seen it this morning with my colleague Christoph, adopted existing standards like Cesium 3D tiles technology, because it is very much an open standard. This is also why we're very diligently working with buildingSMART on our IFC, into improving our IFC exchange technology, but also why we've made great progress in implementing and are still improving on the OGC web feature service, because designing in context in an open data format is so important to engineers. We also created database technology and released it under open source licenses as BIM data in the form of our iModel. Of course, you know, there's a lot of technological hurdles, and as said, we're very committed to overcome that, to open our APIs in the iTwin platform so we can generate or ever increase our third-party developer system our ecosystem of third-party developers. So much for open standard and why it matters so much. But how does it now actually influence this other very hot topic that is discussed in the industry, aka AI? So AI is the hottest topic in technology at the moment. I feel that we're talking about it much more, though, than we're actually using it quite yet. I don't know for yourself, but I've got ChatGPT, I've got all sorts of AI-enabled tools on my computer, and I have not really changed my workflows quite that much, but nevertheless, I know I should, and I know that it promises me to make me more efficient. I'm still waiting for the proof a little bit, but I think as we get more used to it, we will adopt it more. And the expectation, nevertheless, is that it's there and that it's fantastic and it really enables you to do a lot better things. But where data comes in, of course, the AI will only be ever as good as the data you train it on. So if I don't start utilizing my AI tools and the AI doesn't learn from how I use it, then it's never going to get better and my workflows are never going to get better either. In a way, this massive amount of data that we're producing in the industry, that can be utilized to train AI and to actually make it smarter. But that only works if we open that data up and if we have this open source technology available to really enable and make our AI smarter. And that is the one part of it. The other part of it is context. So engineering context also has to be available. While disciplines that we work with, like transportation, energy, water, or cities, they all have different needs and they all have their own different challenges. Some of them are the same, but they're also different. And then each of those sectors has, again, both similar but also unique engineering principles, rules, and logic. And this is what we mean when we talk about engineering context. So the AI needs to be just as aware of that engineering context. And that's a bit more all-encompassing. That's not just the data, it's also how we utilize it and how we actually teach it to apply that intelligence. So if the relevant engineering context has been applied, that's when we actually succeed in training our AI well. So apart from this very wordy intro, I would like to spend the rest of this presentation showing you what AI can be capable of when data and context come together, and how we currently see it applied and how we try to put it out in the industry to hopefully influence your workflow before long, that you actually use it and that it helps you. So the first topic is about finding information. Is the video running? No? Can you press, I need to click again? No, that's the second one. Let's see. Okay. Now it's running. Okay. So I got two examples for finding information. That's the first one, and that's an example where you want to check requirements against standards. So something that's a very typical workflow for a design process. Project requirements and local codes are often not contained in just one document. It's not as if you get a brief that contains everything you need to know, but very often you get part of it on a web page, you get part of it in a file of a document, part of it in a PDF, part of it in drawings that you get by download. And at the end of the day, this information is scattered, and you have to bring it together to actually really get your information about the site and the area that you're in. And let's see, yeah. So hopefully keeps running now. And that is something where an AI can really help you. So large language models can find this information for you, can find it fast, and at the same time provide references to help you find these requirements and make sure you are aware of everything you need to keep in mind. I'm really sorry. When I tried it, it worked no problem. Okay, so it doesn't stop here though, as those large language models can also talk to intelligent BIM models to assess conformance and make sure that nothing is forgotten or omitted. And as you can see, we're actually using natural language here to ask the model to check against requirements, like if something can be built here. And that is, of course, a lot easier than trying to scan through a lot of documents and find that information yourself and manually. The next example about finding data is, and I hope this runs, also gets stuck. The problem with presentation mode. Oh well. So there's a lot of information in your projects already. Projects are not unique. You may have done something already. You may have done similar things in a whole bunch of projects before. The problem is, where are those old files? Is the information locked in old formats? Maybe it isn't even well tagged. You need several applications to open it. And sifting through a lot of material is, of course, time consuming. So if you have a repository for your documents, in our case, that is a Bentley document repository, and you could use AI to interrogate that repository. So while text search, I'll just try to advance this manually a bit so you can see what we're doing. Text search is, of course, nothing new, but hang on. But the new thing is that you can actually use your own natural language and query and actually refine the search based on what you actually need to find. And that is, of course, a lot more convenient than anything we had before. And the search selection that you can then get, you can have a closer look, and you can also, of course, then jump to the files right from there to see if you really have the relevant information. Then another big issue is around automating tasks. And I'm talking specifically about creating drawings. Creating documentation, unfortunately, even in our digital age, will not go away. We will still be required to create paper. And that is something that I've understood is super, super time consuming. Not just creating all those plans, but also making sure they're actually readable. And something very simple that little text blocks that are overlaying each other. And an engineer has to use very expensive and very valuable time ensuring that those little text blocks don't overlap each other, but are moved out of the way. And is actually surrounded by some white space, and we call that white space management at the moment. And thus making sure that everything is clear and readable, that takes a significant time and effort. And see Greg back there, I know that this is something that you're struggling with, but I've heard that from other companies as well. It really costs a lot of money. So we have an example here where we have a neural network that is automating annotation and label placement, and that way we are optimizing drawings for clarity with a lot less manual effort. That was probably the main use case we got from our users to apply AI in is documentation, drawing production, and especially making it a lot easier with the annotations to ensure that these are readable. Okay. Next, let's talk about exploring the design space. And this is about exploring different options and using the data contained in. There's, okay. Yeah. Okay, so some of those decisions may be driven by cost, but there may also be reasons to apply or to go for an option, not just because of cost reasons, but these parameters are up to you and are defined by your project, right? But in any case, evaluating multiple design alternatives can be challenging, because if you do everything manually and you try to bring it together with like costing data, that means, having a whole bunch of documents open, a lot of checking efforts, et cetera, et cetera. So AI obviously can help with that, especially when it comes to bringing data together. Our AI Copilot now is picking the best option based on cost to optimize the site layout. And you can see that when we do this, you pick one option, and then we still do some changes to the layout, and we arrive at the best possible option for our site. A lot of that is also done by telling the AI in natural language what you want it to change. And that is also, of course, a big productivity gain to just rapidly explore, match it against your parameters, and log the data that's contained in there, and then it just brings you a lot more insight. If you are more on the structural engineering side, you can bring AI together with automation. So in this example, if it does run, it's another one that stopped. You can see that we are automating here a big structure. It's a roof structure, and this is not AI. That's just an automation based on a macro where we get all sorts of different options for a steel structure. I think it's exactly 1,680. That is saved now, and now you can again bring additional information in. That's where AI comes in, and you overlay that, and you can literally explore 10,000s of options that way, like this best preferred steel structure, what is the best possible material you can apply to it. So you can see we actually expanded it to 27 million and something. Applied, and that way it can actually go as far as costing and again provide you another layer of evaluating. This is something that would have taken a structural engineer probably a few weeks, but you can do that in hours now if you simulate it like that. Again, you know, need for data openness. The whole structure needs to be open, but also the documents where you find the information that will be aligned with the structure and with the actual model, that also needs to be accessible. Of course, our industry, the design phase is only short, pretty brief in the context of a whole project. If you look at construction, very often takes longer than design, or usually takes longer than design. And then the operations and maintenance phase, even longer. How can you apply AI to track progress? Pretty easy to see the benefits. You can take computer vision of your actual progress on site, of the building site, what's happening, and you can overlay that with a model that you built in the computer. Like the definition of a digital twin, as we heard this morning, is that there needs to be a real physical asset there. So a BIM model that just exists in theory is not really a digital twin quite yet, but this is where you bring the model into reality and where you can actually see a digital twin then really emerging through that added layer of reality. And of course, it also helps you to detect temporal change. You can compare with the intended design. You can spot where there's divergence, and pretty early already spot problems during the construction. That doesn't just apply to buildings. I'm an architect myself, so the building examples speak always a bit better to me than the more lateral examples, but I know we have road and rail designers as well, and in Bentley that is pretty much our core work too. So you can of course do the same, keep design data up to date during this construction, and especially with more expanded projects, it gets even more complicated than with buildings because you're looking at a much larger area. But you can use, if you instrument the field with cameras and position sensors and automated surveying, you can of course use those sensors then to check in, to automatically monitor from check-in points whether your intended design is really what is going to be put into reality. So let's stick with or let's move to operations and maintenance. As said, we are mainly working in infrastructure, and there's a lot going on roads. It's about the status of the roads. Do you have potholes? Are the roads well maintained? Are there any risks for accidents? But of course, there's also a lot of elements in roads that may or may not be visible. I think the video hangs, but for me it's running. I don't know why there is a delay. And the fact that infrastructure is aging is not just a problem in Germany, and we're very keenly aware of it at the moment, but it's a problem globally as well. So AI-powered tools that can analyze IoT sensor data and computer vision are very, very powerful because they enable you to check long stretches of road and actually make sure that everything is visible that is going on those roads, whether traffic lights are not working, whether a roadside is damaged, and whether there's any risk for accidents. Unfortunately, the video doesn't run well. I don't know. Okay, now it's running. Okay. Anyway, you can see what I was talking about. So it's about a network of roads here, and you can check computer vision data, and this is actually being produced by just driving in a car using the camera that you may have, and it will monitor the roads, all the signs, traffic lights that are along those road highways, and feed the data back into your model. And the AI can also help you analyze where there's conditions that are not as they should be. You can see in one of the examples that there is a pothole in the road, there's a traffic cone in the middle of the road, so somebody needs to come pick it up. And these are all things that will be very hard to find if you try to do that manually. You would be driving up and down that road network like crazy. And that way you can use artificial intelligence to detect that, but it's also recorded automatically and overlaid automatically. So pretty cool technology, and especially for government agency who are surveying and maintaining roads, this is a big relief. Now, the last example, a bit in line with what Christoph showed this morning, is about analyzing reality data. I'm using Google, the 3D tiles here for the backdrop, but we also brought in a more detailed design model. And again, we're showing here how you can overlay this data. You can both put it in context, but also put in this little substation to make sure you can actually see it in its context. But you can also enable AI to do analysis, to identify areas that are not as should be, and AI can detect it automatically if there's areas that don't look like other bits and pieces in that model, to help you really be very fast and upfront with any issues during operation and maintenance. And that's pretty much what I wanted to show you. So a quick roundup in where we are and where we see the industry going through a few critical lifestyle phases, life cycles, infrastructure life cycle phases. Again, not lifestyle phases. Thanks for being here. I appreciate it. And I would hand over to the next presenter and hope that the technology is a bit less stubborn.
Hello everyone, and good afternoon. Firstly, a few words about myself. My name is Mauro Coletto, co-founder and CEO of SierraSoft, and I've been working in the field of infrastructure and topography software for more than 30 years. At SierraSoft, I'm responsible for technological innovation, software development, and BIM work methodology. A few words about the company. SierraSoft created and markets BIM software solution for survey, infrastructure design, and construction industry. The products are available in several languages and have been adapted to comply with specific requirements in several countries. SierraSoft has more than 30 years of experience in the infrastructure design and construction industry. About 12 years ago, we began developing BIM solutions specifically for infrastructure, rewriting all our software products from scratch. This update was necessary because BIM radically changes the way infrastructure is designed and managed, increasing complexity and requiring purpose-built software. Adapting pre-BIM approaches was not enough. A completely new solution was needed. BIM represents a significant challenge for software companies, designers, and all stakeholders involved. Today, I want to share how we have tackled and overcome this challenge and how BIM and openBIM have been transforming infrastructure design. Working in BIM means creating a digital representation of infrastructure, a model that integrates design information, geometries, and properties, together with other relevant information needed throughout the life cycle. This enables efficient coordination across discipline and stakeholders, early detection of classic interferences and design issues, improve design quality and informed decision-making, and reduce the risk, cost, and delay throughout construction and operation. The adoption of BIM has a strong impact on infrastructure design. Even if BIM increases initial cost and complexity, it creates significant opportunities for efficiency and quality. This impact can be effectively managed by using effective and efficient software tools, adopting open standards, and following an optimized workflow based on effective tools and standards and consistent with the domain. There are three fundamental openBIM standards to use during the design phase. One is the IFC. It must be in version 4.3 as the minimum for and specific domain to be used, roads, railway, bridges. IDS, the Information Delivery Specification, and buildingSMART Data Dictionary. How infrastructure design changes from pre-BIM to BIM. Pre-BIM design was mainly based on documents and, in some cases, files containing 3D surfaces. Documents were intended to be used by people and could rarely be used by machines. Instead, BIM design is based on information models. Models are created to be machine-readable. And they must also be consistent with the project and the documents. And it is exactly this need for consistency that makes BIM design challenging. The only way to make design effective and efficient is to use software that integrates everything into a single solution. You need a fully parametric BIM infrastructure design software, from design to geometric and data modeling through the delivery of a ready-to-use IFC model in one seamless and integrated process with a single software solution. A single software that integrates features of design and geometry modeling, structure and data modeling, model exchange and federation, and model analysis and validation. How openBIM integrates into the design process. We use IFC, IDS, and BSDD during the structure and data modeling, IFC for model exchange and federation, and IFC, IDS, and BSDD for model analysis and validation. With a parametric system like this, the final model is automatically updated every time a change is made to the design or data. The focus is on design, the result is the model. And now a practical example in how BIM and openBIM have been transforming infrastructure design. It's a demo with our solution, the software is SierraSoft Infra Design Studio. For first design and geometry modeling. The design of the road is done in parametric and dynamic mode with the definition of the horizontal and vertical alignments and the typical section of the different segments. Real-time and repeated checking are performed to bring the road up to standard. The information models are obtained automatically from the design, applying the information modeling parameters, structure, geometries, elements, and data. The main difference from pre-BIM design is the high quality of the geometry required to create a useful digital representation. Geometry are the result of the design, but they also influence the design. Structure, elements, and data must be modeled and mapped in order to be shared. IFC 4.3 allow us to do this. BSDD and IDS support for the data modeling process. The project is modeled using IFC 4.3 structure and elements. The model has been divided into WBSs. The WBSs are mapped in IFC, and the required data was entered for each WBS. And this is the other WBS. In each WBS, we have a lateral and vertical subdivision, in this case roadside, with its FC mapping. And another case is for the substructure, for the substructure, and the other part. The project is modeled using FC 4.3 entities and enriched with the required properties. Inside the lateral and vertical subdivision, we find the elements with the FC mapping and properties previously defined. We here example with the ditch, side slope, and wearing course, guardrail. We can use BSDD service to enrich the information model during the design phase. We enrich the information model by adding classification and property parametrically to the entities. We start with a simple example of how BSDD is applied in design. A geometric model of road defined by its structure and element, but with no properties assigned yet. In our case, for example, the wearing course still has no properties. We open the windows to define the BIM property styles, which parametrically define the properties of the BIM entities. No properties assigned we add to the wearing course. To add properties, we use the buildingSMART BSDD service. We press the BSDD button and select the required dictionary from the list of dictionary available on the buildingSMART server. Information about the selected dictionary appears, showing general data and classes like course and wearing course. We can see the properties of the wearing course class. We add the BSDD classification to the entity property style, which controls the creation of the wearing course. In addition, we can use the BSDD class properties to populate the entities. For example, the adherence property. We can use the IDS standard to validate the model during the design and also for data modeling. We press the EDS button to open the list of used EDSs and add the provided EDSs. Once loaded, the system immediately performs verification of all entity property styles in the project and will report any issues found. The software reports, in this case, 3 issues. The first is the missing classification, FC course according to the BSDD FC 4.3. To resolve it, we connect the second BSDD service, and after finding the course class in the FC 4.3 dictionary, we select it and add it to the wearing course entity property style. It now has 2 classifications are required. After resolving the first issue, the classification, we address the second issue, the missing thickness property. We add the missing property, and finally, we add the second missing property, volume, resolving the last issue. The software now confirms that the model conforms to the IDS used. The model obtained from the design now contains all required elements and properties compliant with the IDSs. Any change in the project or model are automatically updated without extra modeling cost. Here now is an example of how the information model exchange improved design. The project requires the design of an underpass. The road designer sends the alignment and information model to the underpass designer. The underpass designer completes the design and sends it back to the road designer in FC format, so that he can integrate it into the design. In SierraSoft Infra Design Studio, the underpass is imported, inserted, and georeferenced. underpass information model now become part of the project, and you can query the information model and get all the information you need. Underpass information model becomes a support for road design. For example, in longitudinal profile management, underpass reference can be obtained automatically. Cross-section management can also be integrated with information extracted from the underpass geometries. Model analysis and validation. The analysis and verification of the models is performed in SierraSoft Infra Design Studio in the same phase as the road and underpass design. Problems are identified at the beginning and solved immediately with a significant reduction in time and cost. Reports with critical issue can be shared with other designers using BCF or Excel format. Model validation, model and design validation. Okay, model and design validation are key aspect of the BIM and openBIM process, ensuring that infrastructure models are consistent with design requirements and compliant with regulation and standards. Due to time constraint, we will not go into detail here, but this topic has already been covered in my previous presentation in this summit, verification of regulation, functional and safety compliance of a road through IFC 4.3 models. You can also watch the recording of the session for the full presentation. And now the conclusion. BIM is a strategic enabler, fundamental in a modern infrastructure project. It transforms the way infrastructure projects are designed, managed, and delivered. It offers significant opportunities in efficiency, control, and quality, but it could lead to higher cost and complexity in the design phase. Keys to achieving effective and efficient BIM infrastructure design. Native BIM design software, fully integrated and fully parametric, covering design, geometrics, and data modeling, from initial design to delivery of the final information model. Open standards, IFC 4.3 for infrastructure model sharing, and IDS and BSDD for data modeling and data validation. At the end, our experience is that once you start to design in BIM, it becomes the only way forward. That's all. Thank you very much.
Got it. And what I'm here to present is not the entire LeapThought system. What I'm here to present is just the AI machine learning functionalities. What we've tried to do, and I mentioned this yesterday, we started as a group of systems engineers looking at a problem from a distance. Not necessarily architects, not necessarily design construction engineers, but people looking at a system and a process of building, from design to supply, to build, to handover, to maintenance and monitor, to takedown, cradle to cradle. And obviously, many systems are not designed to provide every element of that role. Everyone has different softwares to do different components of that, which is great. That makes sense. That's how the world was evolved. Now, technology has reached the level that this information, to be most useful, has to be integrated, or can be integrated. Whereas you're no longer thinking about managing a project, you're managing a profile of projects. You can be a city managing an entire stream of production from cradle to cradle, from build up to takedown, and have your full data sets integrated across. The challenge that we had to our work was that there are a lot of systems in place, and I think my colleague who just spoke also is looking, SierraSoft is looking at that same problem. How do you integrate software systems that were not designed to be integrated? Right? Isn't that the question? And on the panel yesterday, our Dutch colleague mentioned, well, we need more APIs. And our challenge was basically, and I like that, I got a note here, so I want to hear from this in a second. Our challenge was to figure out how we could link in to everybody's data without disrupting it, but to bring it across a level of quality that was equivalent to what was inside the native rendering. This has been a serious challenge for many people. That's the step number one. And why? So you could get it all on an integrated platform where this can then be shared, cross-shared with all different users, whether or not they were in that same architectural segment. I mentioned the notion of MALD, Model as Legal Document, and I mentioned Will Sharp from HDR driving this. Why did I mention that? Well, partly because I'm a lawyer. I think one of the biggest problems in construction are lawyers. Liability issues, failure of being sued, which makes companies very shy. It makes them very shy about trusting data that's not theirs. So from what I've seen, you get a pre-architect who does a design, it's approved, he gives it to the architect, and the guy says, I don't want to use that design, I don't want the liability. I'm speaking almost as an American because we have so many lawyers. In the state of California, 1 out of 10 people is a lawyer. So avoid that state if you can. In any case, the architect then passes that design to the engineer, who rejects a lot of that data and redoes their own because they don't want the liability. There may be cost issues as well. But what I'm saying, each step, it's rejected. The notion of having open standards in ISO 19650 is that you can actually transfer that data across. You can get approvals, have it verified by a state authority, and therefore trust that data source as the one sole source of truth and continue on in your construction process. What that does is build an integrity across the loop. It has not solved the problem that everybody still uses different software. As long as it works within certain specifications and standards. So obviously, our interest in BSI is driving open standards because it helps us to drive the model. All right, I'm going to do my best to just show you. I'm going to jump my slides because I want to start with this first. Hard to see because I'm going to have to talk to this because the screen is too small. What this is actually showing is that on that bottom line, what it shows is, and I'll read for you because you can't see it here, is from data creation to data acquisition to data processing to data storage, data enrichment, data analysis, data visualization, data exposition, and data replenishment, all on the same line, all on the same platform. And by the way, all on a single screen. You want your users to only have to look at one single pane. You don't want them to have to face serious complications in terms of data sets. So what this document is actually trying to show you, but the screen is not prepped for this, is that we go from digital design to digital manufacturing, fabrication, construction, asset delivery, across every one of the steps, incorporating the entire process in each, and then passing it over. This design was an approach that was basically supported by and requested by different governments. One of our first starts was in New Zealand, Auckland. And Auckland had a system where they had 9 different community transport organizations, and they decided to make one. And they asked us to come up with a system that would incorporate and integrate the various different data sources into a unified source, but would not necessarily threaten the existing users who were not familiar with something besides their native use. So we developed, over the course of 9 months, a system which was able to incorporate their entire data set for all of their regional transportation planning. And it's up and running now. This has been up and running for over 10 years. This is an interesting Singapore case of a network. I mean, Singapore's Land Transport Authority has incorporated LeapThought as the baseline technological platform for all of its construction. Why? Because they can plan on it, they can build on it, and they can monitor on it. The dashboard set that comes out of this is extremely rich. I'm not going into that. I'm just going to focus on the AI/ML side. But in essence, because of the capacity to digest data at a petabyte level, we're actually able to help them do all of their planning and also to manage that entire flow of construction. This is an interesting case. I like the heading of this the most. I mean, the notion of about modeling or managing your entire portfolio of smart estates. Singapore is really big on smart estates. As a small country, they have to compete against large neighbors, and they have to always be cutting edge and having the best. Smart estates has enabled them to attract different types of industries to basically compete out of Singapore. And we have had to help them with the build process. So in essence, every time they build one, They have that full data set already engendered in their systems. LeapThought does not maintain or hold their data. The data belongs to the enterprise owner. And they're able to apply those same models again and again for their subsequent construction. It saves a lot of time. It saves a lot of money. Public housing is another case where, in essence, the entire portfolio of public housing in Singapore is managed under a single system. Again, I repeat, it does not stop people from using whatever systems they're using for their architectural design or their engineering, but it provides the enterprise owners with the capacity to extract information from all of those systems and manage it in one singular line. And frankly, it enables everyone else to communicate across it too. And we're not just talking about specific entities, but all the way down deep into the organizations. Fulcrum can be configured such that there's various levels of users, from the architect all the way down to the supervisor engineer. There's various levels of correspondence. And the beauty of the system, especially from the perspective of an enterprise owner, is all the data is captured. This is your digital twin. By the time you're done, you have your twin. We're not going back in time and then trying to create one. It's being developed through that entire construction process. CoreNetX. CoreNetX for me is an important step forward in showing the value of AI and machine learning. CoreNetX basically has been, or CoreNet was a dream for Singapore for a long time, but basically what it is setting up a system so that all 8 of its regulatory agencies can be online at the same time, providing virtual approval at every step of the construction process. That sounds quite simple. It wasn't simple. And we're talking about the case of Singapore, which is a single city-state. Why is it not simple? I was having this discussion with Nick from the UK the other day, who worked on earlier versions of Singapore's CoreNet. It's not simple because you have to be able to ingest every law, every regulation that exists. And in the case of Singapore, there are thousands and thousands of regs. And in the case of the countries that you represent, there are many more. I'm currently living in the United States, and it's not just a city's regulations, it's a county's regulations, it's a state's regulations, and their federal regulations. The first step in the case of Singapore was having to go through a very extensive process of consensus with the quality control personnel, the QP, the people who actually would interpret and agree to an interpretation of the language for regulation. I mean, is this a panel? Is this a screen? Is this a wall? For AI to work effectively, you have to agree so it understands what it is that you want it to do. So this was an extensive process that we carried out. In the US, we're beginning to experiment where there are projects which are under one sole line of jurisdiction. Airports, for example, because that's under federal jurisdiction. If you start working with construction in San Francisco, you got to deal with the city, county, state. It's going to happen, but it will require a lot of background work to make sure the AI systems and the machine learning systems have access to the right data, or you're guaranteed to fail. How was this done? In essence, CoreNetX is based on having all these capacities in terms of what it can look at. It can look at, and these are all based on the requirements of the 8 different regulatory agencies. They told us what we needed, we bespoked. I mean, I used to work for Microsoft for 10 years. Microsoft will not bespoke anything. You want to change in the rules, regs, forget it. Our way or the highway. We bespoke. I imagine SierraSoft does the same. We ask them what they want, and then we redesigned a system to reflect their requirements. And we also know as a result that whenever you go someplace else, you have to do the same thing. But that's quite natural. But there are certain uniform, universal cases. Everyone needs geometric analysis. Everyone needs parametric analysis. Everyone needs pathfinding, setback projections, computational analysis, shape-related analysis. This is all bread and butter to the construction industry. So for us, we have therefore incorporated and tabulated these in different segments. And you can't see these numbers. I'm really sorry about the screen set out. But when I'm looking at this, I mean, the number of rules that we had to target in the case of just BIM quality checks, just for the quality checks, it was over 21,000 rules. In the case of rules targeted for setbacks, it was 150 rules. In the case of rules targeted for test results against parametric analysis, it was over 150,000. There's a lot of data that you cannot do without using AI and machine learning. When we're talking about AI, we're not talking about simple AI. We're talking about industrial grade strength AI. This is powerful stuff. It's not that simple. And I can show you some examples if I'm able to run these screens. I'm just hoping that I'll be able to get these things to play for you. This is an example of a transport system in New Zealand, where basically what they're doing is we're doing cross-section cuts, comparing models. The different colors help a regulator understand, or help to understand what changes have been made. Maybe an initial design went in, and it came back with checks, and then they redid the building, and then they carried out a second level of cross-checks. So the purple in this case are added, the green were modified, yellow was a removed concept. So that's what that one was showing. See if I can move on. This is a building. We've obviously, we cut our teeth on vertical construction, but we're trying to focus as well on horizontal. This is a demonstration of how you're able to incorporate 2D data across. So our machines can now read 2D data, incorporate those back into 3D models. So this is the AI system that we have, which is called Genie. It's basically what it's doing. It's reading this 800-page document and summarizing information that's specific to what's being requested on bus shelters for the specific project in Singapore. There was a comment that was made in the panel yesterday about IT has to be very simple for people who are simply not that IT friendly. So this simply lets people ask questions. Give me the sizes for bus requirements. Give me the breakdown or the skeletal analysis for fire, whatever it might be, and the system can basically read it and tell you this, which is quite nice. It's like taking that next step to kind of bring simplicity to the entire project. This one shows you how you're scaling out a building. So it's removing the shell of the building. It's going to remove the external shell. And it's going to, at this point, we're looking at different disciplines. So this is now the discipline that's underneath the shell. We're telling it now to take out the fire discipline, remove that, and you can just keep going deeper and deeper into whatever level you might need. Now, if you're a regulatory agency and you're responsible for fire, you don't necessarily need to see the whole building. You do want to see exactly what the fire codes are in the application. So this is now just going to do a cross-section of that same building. These are actually real use case examples. I'll come to you in a second. Go ahead. Please, yeah, go ahead. We're able to hide it. We can hide it and then we can re-show it. No, we take them. So in essence, we're ingesting the existing data sets that are provided, building the model as is, but because it's built on different levels and from the different elements, then we're able to remove them as required for a specific user. So you start, your BIM model is there. You then can break down and take away segments so you can then dive deeper into the other specific components. By the way, this is not a 15-minute presentation. My CEO usually does this in an hour, and he basically does it an hour based on people telling him what they want to learn or what they want to look at. But we don't have that much time. But it's sometimes nice to see that behind all the talk, that there is something going on. And this is AI machine learning driven. It couldn't be done otherwise. And again, remember, these systems were probably built on Bentley or Autodesk, et cetera, so we've had to incorporate and ingest their data sets. Some of them are harder than others. Some of them are trying harder than others to make things open standards. But we are able now, we've got some, if you look at our staff, I'd say 75% of it is PhDs in computer science and architect and engineering who just are doing algorithms to try to understand how to make AI more effective in its deliverables. Again, here's that cross-section look. Let me see if I can get this one to go on. And I'm coming back to this one because I want to show one more thing, which is, and this will be my last video. This look is also now looking dimensionally. We had Esri here, but he's gone away. But this is actually, we were able to capture Esri data or any other geospatial data and incorporate it into all of our BIM work and then carry out that analysis. So you're actually able to do levels and analysis. You can capture the data from the actual site. We've spent a lot of time trying to do that integration. And actually, now that Esri has openBIM, our next offer to them is going to be, let's put Code Checker right on top of it. You can build right on top of that system. And that's where we're going now. This thing is going to end by asking for some structural data on this bridge. Elements, how many beams and columns, and this one's isolating the elements, 17,043. This is a specific bridge also in New Zealand. I'm going to skip that. I've made this comment, again, time is short, but I wanted to say that in essence, it's not just AI. It's like intense, rugged, industrial scope level. The amount of data that it has to manage is significant. Again, those who question whether or not you can do regulatory checking mechanisms, as a lawyer, I understand, because the problem will always be interpretation of the rules. And the rules are not always in line. But the more that you can get organizations, and this comes back to this organizational management, non-IT technical argument, but the more that you can get organizations to work effectively together, to have uniform language, the more easy it is to apply IT solutions and machine learning and industrial grade IT to problem solving. So functionally, that is, in a nutshell, what we've been doing in terms of AI and ML. This is now running on about $300 billion worth of projects throughout the world. It's pretty cutting edge. We're really happy with the results. Singapore is a great test case. That's why we were happy to have the last buildingSMART summit there, because people could just talk to people in the government. It's always better to listen to a user than it is to listen to a company rep. But the fact of the matter is, at this point in time in Singapore, just as the test case, 90% of all construction's on this platform, which seems to indicate that they're finding it to be effective, responsive, and able to meet the vision that they set up for their vision of a digitally managed infrastructural world. It's portfolio management, moving well beyond project management. It's in essence enabling people to start where they are, and as a CEO, to be working on one single screen, one pane. You know what, some of you are CEOs, some of you work with CEOs, they don't want a lot, but they want to see those nice dashboards, and they want to be able to see the content. People below, we need to see submittals, we need to see requests, we need to see that whole overflow of information. So LeapThought, cradle to cradle, from design, pre-design, design, supplies. We do a lot with DFMD, which is important in Singapore as a case point, through to construction, handover, and then maintenance. Whatever the systems that the government is using as native files, even ending up in Maximo, if that's where they put things, our job is to make sure wherever it is, it stays intelligent. We want it intelligent, we want it iterative. We also don't want to make people who are using other systems feel that they can't. We want them to keep using what they know. That's fine, because we've developed the capacity to actually extract, digest, organize, integrate, federate, and that's what's providing this possibility for holistic intelligence. Very brief, I know, but I think that's the time that we get. So I'm stopping on the LeapThought side. I'll just end with this notion that I really think that the key for all of us and the reason that we're here in buildingSMART is because this gives us the venue to actually move this entire process forward. Some countries are much more advanced than others. I've been in the most advanced and I've been in some of the least advanced. In fact, I live in one of the least advanced, which in my mind is the US. We're not nearly as far along as they are in other countries. The more that we're able to share and learn, which is what I see buildingSMART is about, seeing is believing, as Calvin Cam, the US chair president, talks about, is important. So I'm happy to see all of your examples, all the cases. I'm sitting in a meeting upstairs at the same time with China, for example, the 3 major Chinese construction companies who are on the Strategic Advisory Council for buildingSMART. And the work that's being driven there is outstanding, supported by many of us here. Middle East, right? Northern Europe, Germany. There's so many great examples. But we always have to keep thinking about what's next. And this came up in the discussion yesterday about IFC 4.3, IFC 5. In my mind, without even knowing what it might be, I'm already thinking of IFC 7. Maybe it's because I used to work in Microsoft. You know there's always going to be a new evolution. But the fact is, we always have to help people along, move them forward, and understand that we're not talking about the construction industry today. We're talking about the construction industry in 5 years from now, because that's how long it takes to put up a building. And we should also be talking about 40 years from now, because that's general lifespan, 40 to 50. Do they have the data already to know what's in that building? Can they take it down? What do they recycle? What do they save? Do they know how it was built? If something happens in terms of liability, this is the part that gets me, through this system, you could actually track all the way back to the decisions or the overrides that might have led to a decision. You might have had a clash detection in your building, and someone might have overridden it, but if they do, in this system, it captures it. It says, okay, they overrode it, this is the reason, and it was agreed to, but now you can track. So it really enables kind of a comprehensive management approach fed by all the different systems that we have in place now in terms of data sets, in terms of design, in terms of build. So these are exciting times, and I know that we're not the only company doing this, but I think we're one of the better, and we're always happy to continue our work with all of you. So I'll end with that. Thank you.